6, just to give you a preview before we actually dive in. We've been spending a couple of days now discussing how throughout your entire mathematical lives, you've always plotted points in x comma y form until recently when we've introduced polar, and our points have shifted from x, y over to, anybody? R theta, polar points, right? And what we're going to talk about today is a natural question that I get from students sometimes who are particularly intrigued by this. Ms. Blakely, if I have a point in polar, is there a way to transform it into rectangular and vice versa? If I have an x comma y, can I change it to r comma theta? The answer is yes. I'll show you how to do that today in both directions. How did it go yesterday? Good. Myra help you?
Yes.
Y'all talk to Myra?
Yes.
Good. Sometimes she says you don't like to talk to her, but you talk to her, she helps you, she had the key. So I hope that you talked to her.
She had the key?
She had the key.
You like success?
You liked the sub. She had excellent things to say about you. So I'm glad that y'all were well behaved and you got along with the substitute. I appreciate that. I will be grading that. So if you were absent yesterday, make sure that you get a copy of that stuff from me because like I said, we only have about 3 grades left this 6 weeks. You want to make sure that you prioritize everything we're doing in polar. It's its own standard, so it has the potential to have a pretty big impact on your average, right? You should also make sure you're going and checking home access quite frequently. I'm updating on a regular basis, and things are pretty current right now online in the gradebook. Okay, so originally we were scheduled to have an exam on Tuesday of next week, the day before senior signing day. You remember this from our calendar? And I've decided we're not going to have a test that day. We have had to skip around a lot because of testing. We've had like strange schedules and I haven't been able to cover as much as I want. I do still need to have some kind of assessment, but it's not going to be as big and scary as our tests usually feel. It's also going to be a little bit more rigorous than what I would just call like an exit ticket or a quiz. I've coined it not a quiz, not a test, but a quest. That we are going to on Tuesday of next week. It's going to cover 3 major skills. So I want to make sure I say what they are right now so that you're prepared for that, and we'll spend Monday reviewing and getting ourselves ready. Skill number 1 that we are going to be assessing on our quest. Your ability to plot points in polar. You got a nice review of that yesterday on the front half of that assignment that I left for you. I did try to trick you on some of those where there was more than one answer to a given question, so be aware that's like a nice skill that's going to happen, that's going to show up on your quest. Second skill was that matching that you did where you had graphs of polar curves and equations and you had to appropriately match them. That's also going to be a major part of your assessment on Tuesday. Third skill will be what we talked about today, how to convert from rectangular to polar and polar to rectangular. There is a lot of stuff in this packet that we are unfortunately not getting to learn. That's because our timeline is quickly moving right along. We'll take our assessment on Tuesday, we'll celebrate our seniors on Wednesday, we'll come back Thursday and Friday for 2 days of common assessment review. We'll go home for the weekend, we take our common assessment Monday and Tuesday of the next week. In class, but in 2 parts, a Monday test and a Tuesday test. Wednesday, we'll have class. I'm not 100% sure what we're going to be doing yet. Bless you. Thursday is service, Friday is a trip, then it's Memorial Day, and it's that last week of school where we have half days. So we're pretty much done if we can get through our quests and our common assessment, okay? And in order for us to be successful, we're going to have to talk through this final skill that's going to be assessed on our our assessment next week. Now there's a lot of words here, so I want to talk you through something that we spent quite a bit of time on last 6 weeks ago, back in like January, February, when we first started talking about trigonometry, okay? There was a day, once upon a time, when I gave you XY axis, but instead of a point or a graph, I actually drew a triangle inside of that XY axis with an angle down here. And maybe I told you that the X value length was 3, the Y was 4. First thing we did was geometry, and we found the missing side. Abrielle, what is it? 5. What did you do? Okay, so you just memorized it, but what formula could I use? Pythagorean theorem. A squared plus B squared equals C squared. We could find our missing side. And then the logical next thing for me to ask you was 6 ratios. I always wanted sine of theta, cosine of theta, tangent of theta, right? And then the other 3 were just reciprocals, and they were called cosecant of theta, secant of theta, and cotangent of theta. And you got pretty good at this, but it took some practice. And the major thing that we had to do to analyze these 6 trig functions was remember ratios. At the beginning of this lesson, we grounded it in geometry, and you guys were just using SOHCAHTOA to do this. Opposite, adjacent, hypotenuse. But I tried to push you after a while to start utilizing new language instead of the old language of opposite, adjacent, hypotenuse. And once upon a time, we used ratios of y over r, x over r, and y over x. And what did I do to those ratios to get my last 3? Flip them. That's it. Reciprocate. This was r over y, r over x, x over y. And you did it. You got 6 answers. You were good. Today, we're going to talk about this new idea of converting points from polar to rectangular and vice versa. And that skill is going to rely hugely on these first 2 relationships that we used back then. We will talk about this one a little bit toward the end of class, but it's mainly these 2 on top. So what we're trying to do, and there's a lot of words over here that I'm not really going to emphasize, but what our first major skill is going to do, or is going to ask us to do, is to take an r theta and change it to an x y, right? So what I want to do is try to find a definition of x in terms of r and theta, because I'll know what those are, and a definition of y in terms of r and theta that I can then evaluate, do some math on, and solve. And if I look at this, let me draw your attention to the first one. Sine of theta equals y over r. Thinking algebraically, what could I do here to get y by itself? Multiply. Heard a couple different things. Multiply by what? R. That'll isolate y. And y equals r times sine of theta. And here I now have a definition of y in terms of r and theta. That's what I want in order to accomplish my goal over there. I'm going to do the same thing with the x, right? Multiply both sides by r, and it looks like x could potentially be expressed as r cosine of theta, and now I'll be able to get an x and a y and accomplish this goal. This is going to rely hugely on your unit circle. Some of you love the unit circle. Some of you make noises like that when you mention the unit circle. Oh, my life is so hard. The unit circle. It'll be okay. Let's try an example and just dig in and see what you think. I shared something with first and second period this morning about the unit circle because a lot of them didn't have them, and they were like, Miss, why didn't you tell me this forever ago? It's so easy now. And it's like, my bad. I forgot. So I'll show you a trick. Maybe you'll like it. I don't know. We'll see. But let's try a problem first, okay? Let me erase all this scribble scrabble. Our point is 4 pi over 6. The instructions are find the rectangular coordinates for this point with the given polar coordinates. When I see rectangular coordinates, I annotate and I remind myself that means I'm supposed to find an x and a y given the polar coordinate right here. I'll also come under the point and put like a little r theta so I know exactly what I'm dealing with, what my r value is, what my theta value is. We could plot that point if we wanted to, by the way. That would mean rotate to pi over 6, count out 4 rings, put a dot. We're trying to figure out, if I were to do that, right, I would rotate out to pi over 6, and I would count out 4 circles, and there would be my point P. What we're trying to do now is figure out what the corresponding horizontal and vertical distance is for that point right there. This is our visual of what we're accomplishing right now. Bad circles, sorry, those are ugly. Let me erase that. Okay, my best practice. start with your formulas. Record them on your paper. Two formulas are x equals r cosine of theta and y equals r sine of theta. Always start by recording those so that you know exactly what formulas are going to be important for you in this process. If you anchor yourself in the formulas and you've annotated your point, I'm hoping the next logical step is to plug in the stuff that you know, right? R is 4, theta is pi over 6. That means to find my x, I'll need 4 cosine of pi over 6. And to find my y, I'll need to evaluate 4 sine of pi over 6. Substitution. From here, the only thing that's challenging about this is not the 4, it's the cosine of pi over 6 and the sine of pi over 6. That's going to be the piece that I really need to think about. And I know a lot of you really organized, wonderful people just pulled out golden papers with unit circles on them. And you'll go to pi over 6 and you'll just grab a number. I need you to make sure you're processing this without having access to that resource too. Because you're not going to have it on your test. You're definitely not going to have it on your common assessment. So we need to get better at figuring out how to evaluate this without our circle.
Can you multiply by 180 over pi?
I can absolutely multiply by 180 over pi. That's to convert the angle into degrees, which we all know is a more friendly unit than radians. What happens to the pi's? What's 180 over 6? 30. Very good. I usually just ask myself what's 18 over 6 and then add a 0. 30. And that's a really important thing right here, because if I know what angle it is that I'm looking at, I have a much better shot at evaluating cosine and sine. So let me share with you. Here's what I shared with first period where they were like, oh, Miss, why didn't you tell me that? I don't know, I forgot. I didn't think about it until last night when I went to bed. 30 degrees, can we agree? 0, 30 is just a little bit up above. It's actually the first angle of my unit circle. 30 is right here. So, what? It's not straight? Okay, I appreciate the constructive feedback. Still not straight. Hey,
Get it right on the baseline.
Okay. Here's my issue. When I get the converted angle and I have a result of 45 degrees, that's my favorite one. Because 45, even if I haven't memorized my unit circle, I remember it's right smack dab in the center of a quadrant, and the x and the y are the same. 45 is the best. That's where it's square root of 2 over 2, square root of 2 over 2. So I'm hopeful that we just remember that one. That's not the one I'm giving you a hint about. The harder skill is distinguishing 30 versus 60. Where's the 1/2? Where's the square root of 3 over 2? Because sometimes we get those backwards. So what I told first period to do is when you find your angle, which in this case is 30, draw a triangle right here. Do you see my triangle?
Yeah.
I need the x and I need the y. Can we all agree the x of this triangle is way bigger than the y? Mm-hmm. This is a longer side length than the vertical. And if you can establish that, which one's bigger, which one's shorter, the good news is the longer side, which is my x, always will have the 3. The shorter side will always have the 1. And then you just got to add the baggage to that to get your proper point. That means the 3 gets a square root, and they're both over 2. But the long side's the 3, the short side's the 1. Every time. That works for 62. If I'm up here, here's 60, right? Short side is the x, long side is the y. Short gets the 1, long gets the 3. And now I just make them complete points. There it is. Perfect. I love it. Thank you for the support. Okay, so I annotated in red what I need. Another big thing that you guys have trouble with is once you get your point, how do I find the cosine? How do I find the sine? Which one's which? I'm hopeful that if you've written the rule down, you won't have a hard time with this. You have to have anchored yourself in the rule. And when you ask yourself what's cosine of pi over 6, if you're doubting if that's the x or the y, just look on the other side of the equal sign. It is the x. So at my point, the x is square root of 3 over 2. Let me write that in red. I have my 4. the cosine that I just found is square root of 3 over 2. When I do the same thing for the y, I bring my 4 down, and maybe I'm in confusion here, like sine of pi over 6, what's sine? Just look on the other side of the equation. Oh, it's the y. So I go to that place that I was just at, and the y is 1/2. And here now, the only thing left to do is simplify, if you can. Sometimes you won't be able to, in this case you can. 4 over 2 is 2, I hear Lewis saying, and I've got a root 3 attached to that. And 4 times the half over here is 2. So what's really cool is that this point of 4 pi over 6 in polar is actually the same as the point 2 square roots of 3, 2 in rectangular coordinates. And that's my final answer in the red box. Can we try another? I heard yes, I'd love to, Miss Blakely. Let's do another one. Okay. So as we're getting started, this is still pretty new. We start the same way. We're asking ourselves, we read the directions, find the rectangular coordinates, the x and the y, for each point with the given polar coordinates. That means this Q point I have is my r and my theta. I need an x and a y. I've got a formula for x. It's r cosine of theta. I've got a formula for y. It's r sine of theta. If you annotate all of that, I'm hoping the next line is very natural because you're looking at what you got and you just tell yourself, oh hey, r is -2, theta is 135. Let me go substitute in here. And it's definitely those trig functions that make me pause and reference my unit circle to finish this thing up. Okay, so again, to walk you through this process, I think about my circle. This one's not as bad because I don't have to convert. It's in degrees for me, so I can just start my rotation. I'm starting at 0. By the time I make it up top, how much of a rotation have I made? 90. If I go all the way to the next x-axis, I've gone too far, right? So back it up, 135. It's actually smack dab in the middle, right? Smack dab in the middle. So if you want to use my new trick that I just showed you on the last one, you draw a triangle. And with this one, it happens to be a situation where because I'm directly in the middle, I have a hard time figuring out which one's longer, which one's shorter. Those are identical side lengths. And that's only one situation. Square root of 2 over 2, square root of 2 over 2. So that's helpful, I think, but you have to make sure you're drawing this accurately or else you might get yourself mixed up. But here I've got an x and a y that have the same value. And the only thing you can't forget to do is ask yourself, well, wait, should one of those be negative based on where I'm at? And it's the x, right? Because I'm backwards on the x-axis and positive on the y. So here's my point. Beautiful. So I really think we need to start doing this more, especially as we gear up for our common assessment, because some of you, when we did this last couple units, you were trying to memorize that whole circle. And that's a very daunting task to try to memorize all the angles, all the points, and everything to make a complete circle. But really, if you can get to the rotation and draw a triangle, you can piece together intuitively your point and have what you need for that problem. And it ends up being a waste of time to draw the whole circle every time when you only need one point. Okay, so when I come over here to cosine, what's cosine? I'm not sure. Let me look over here. Oh, the x. So that's -2 times negative square root of 2 over 2. I come over here, I need sine of 135 times that -2. What's sine? I don't know. Let me look. Oh, it's the y, square root of 2 over 2. Last piece is to simplify. And I see everybody else saying yes. Let's cancel some 2's right here. And let's cancel those negatives. Looks like my x coordinate is square root of 2. Here I can only cancel the 2's. The negative sticks around and I've got negative square root of 2. So my rectangular point is square root of 2 negative square root of 2. Let's get you guys to try B. It'll be a nice one where I think the triangle will help you out, and we will compare answers in about 2 minutes. Let me take attendance cell. I don't help each other for sure. And try, even my folks with your unit circles, to do it without using them.
The bigger number is going to have more stuff on it, so that's why we have to write it. And then we look at this triangle. The x is the smaller side, so that's why we have 1. And then this is the longer side, so 3. And then this one is 3. Is why we put 3 here and some more stuff. And then this one, since they're kind of like the same length, the pointer is in the triangle. This isn't really a point. Because this is on the x, and this is like the imaginary y. Or on the y-axis. Just look at the bottom one. I know, but our so this will be 3 and then 2
you write it in the one negative. Was that everything?
Huh? It's like my last one.
All right, my answers are, and I'm actually not going to show work. If you want to see anything in detail, you let me know, but I want to give students who got to an answer an opportunity to just get feedback right away. When I change this to rectangular, we're looking at a point of -3/2, or -1.5 if you're a fan of decimals, and 3 square roots of 3 over 2. Okay? If you had a hard time with that, you should verify that you are looking at the right point. 120 is closer to the y-axis. The x is shorter, -1/2. The y is longer, square root of 3 over 2. There's where that comes from. Are you liking the shorter, longer trick? Is that helpful? Cool.
Is that going to work for the bottom one?
Yes. It's definitely going to work in the bottom when you draw those triangles, and the question you always have to ask yourself at the end is what's negative based on where I'm located. Great question. Cool. Okay, so in terms of your homework, 1 through 11, what we just went through is 1 through 6. And earlier this morning, Alberto, when we had work time, he got 1 through 6 done in like 3 minutes, and then he put more of his energy in 7 through 11. Okay, but I want to model those ones for you too real quick so that you're comfortable doing the whole thing for me, starting in class and finishing over the weekend. Okay, so on the back. The other skill then is going to be what happens if I give you rectangular and ask for polar. just going the other direction, okay? And it's going to require some more processing of our circle, but very similar style of setup here with some different formulas. So what we saw in the previous work was that we really needed x equals to r cosine of theta and y equals to r sine of theta in order to move from polar to rectangular. Now I'm going to go backwards from rectangular to polar, and the formulas that I need are going to be a little bit different. When I showed you at the very beginning how we handled this when we first learned trig, you told me that if I gave you the x and I gave you the y and you needed the hypotenuse, what geometric formula did we use? Pythagorean theorem. We called this A, we called this B, we called this C. The formula I'm going to use, I'm just changing the names of things to match the rigor of the problem that we're doing. And it's going to be r squared, you see that right here, equals x squared plus y squared. Same thing, but I'm changing the names of A, B, and C to x, y, and r. And I hope you can realize this is not going to be very difficult because I'm giving you an x and a y. So to find r, I'll just plug in and do some computation real quick to a Pythagorean theorem question. The harder process is going to be to find theta. Back in the day when we used to do this, we would ground it in SOHCAHTOA. And you guys would tell me, oh, well, I know the opposite and the adjacent, so that means tangent is going to be what I need to use to find my theta. Same thing is true. We will use the relationship tangent of theta equals y over x to help us find our angle. Let's try one and see how you're feeling about this before you get some work to do. Yes, great question. We're not going to use secant, cotangent, sine, cosine. It's always going to be tangent when you want your angle. Good question. All right, so let's try one. All of this is summarized in the key concept box, but I think for the sake of time, we're going to jump right into a problem. So, read the instructions. Find two pairs of polar coordinates. How do we write polar coordinates? R theta. For each point with the given rectangular coordinates. So I'm giving you rectangular. That means 1 is an x and negative square root of 3 is a y. Annotating all of that will be helpful so you can figure out which formulas you're going to need. So my goal is to find r theta. That means I'm going to start with r squared equals x squared plus y squared, something that will get me an r. And I'll need to start with tangent of theta equals y over x, something that will get me a tangent, a theta. We want a radius and we want a theta. Substitute, right? What is that? My computer? Your computer. Okay. So just like last time, after we write our formulas down, we substitute in where we can. Not hard, right, if I've annotated my point appropriately. So r squared needs to equal, let's see, parentheses, a 1, where the x was, with a square on top, plus parentheses, a negative square root of 3, where the y was, with a square on top. Some stuff cancels over here. Let's do the 1 squared first. What's 1 squared? 1. What's negative square root of 3 squared? Positive. Negative square root of 3 times negative square root of 3. 2 negatives, cancel. Square root and square, cancel. I'm left with 3. What's 1 and 3? So r is 2. Square root. So that's exciting. I'm already halfway done, and there was really no trig involved in that, right? That's just like math, algebra, some math that we have to do right here. First piece done. Here's the part we're going to need to really think through. When I substitute into my second formula, the y I replace with the negative square root of 3, the x I replace with the 1. And when I'm looking at this, we are supposed to think through, this is what we used to approach this. We ask ourselves the question, what angle has a tangent of negative square root of 3 over 1. That's what I'm trying to figure out right now. If I look and think about my circle, where is it where I could take the y, divide by the x, and get this answer? This is hard. And I actually wish I had not taken all of my posters off the wall, because there used to be a sign around here that looked like this. What is that? Right there. All students take calculus. What did the T actually stand for? Well, yes, all students take calculus, but in terms of trig, tangents is what we meant here. What this mnemonic device meant was that in quadrant 3, all the tangents are positive. Our tangent is negative. I don't want to be here. What did the A stand for? Everything's positive. It's all positive. If I want a negative tangent, do I want to be here? No. So here's what I'm able to kind of infer. The reason that we're asked for 2 answers is because when I do this quadrant analysis, I could actually get an answer in quadrant 2 and in quadrant 4. And I want to try and write both of them right now. So what I'm interested in is really digging in. There are 3 potential answers here, right? I want the one angle that's going to get me a y over x that looks like that. 3, right? And really, let me give you some advice. Oh, because of the ones over here. I'll show you a trick to get the one over there. I'm not going to consider the triangle in the middle. It's square root of 2 over 2, square root of 2 over 2. And if I divide things that look identical, I'm not going to get that. I'm going to get a 1. Okay? So I'm not going to even consider the angle in the middle. That's got square root of 2's all over it. That's not what I'm interested in right here. So I'm going to want either this one in red or this one down here in green. The one in red, let's think through this. The shorter side is the x, 1/2. Longer side, square root 3 over 2. And Edith, where does my negative go? On the x. Beautiful. And really, I only have to think through it once because I know the other one's just going to be the opposite, right? So I'll put the square root of 3 over 2 first and the 1/2 second with the negative on the x. Okay, in first period, Christopher was like, it's the second one. I know it. He was confident. And we checked and then he saw, oh shoot. So let me show you how you would check if it's just not immediately obvious. You take the ratio of here, the y over the x, and you do the math. What do I mean by do the math here? KCM. 1/2 times 2 over the square root of negative square root of 3. What happens to those 2's? And I've got very close to what I want, but upside down.
So it's got to be.
So it's got to be together. Now, what is the angle of the red triangle? It's not 90, but it's 120. Next angle after 90 is 120. Okay, so here's what I'm getting at. My R, we decided, was 2. One angle that satisfies that equation is 120. Rather than draw all 3 triangles over here and do that again, what we should be able to deduce from this is that if it was 120, the other angle is going to be directly across from that in quadrant 4. And if you think about that as a rotation, how many degrees do I need to add then to get over here? 180. That's half a circle. And 120 plus 180 gets me my last answer of 300 degrees. This is a much more rigorous skill, though, going the other direction. Okay. Now, we still have quite a bit of time, so we're doing good. I don't know how much time we have, actually. I'm kind of lying.
4 minutes.
8, 9 minutes?
So why isn't it -2? 4. If the points
-2 is absolutely another great answer. I default to the positive over here, but negative is perfectly sound as well. Hold on.
See how the numbers going to?
120, don't you go backwards?
You're right. Abrielle's absolutely right. Hold on. I was just checking that, right? If I went to 300 and then out to +2, that's going to get me a point down here, which satisfies that equation, but is not this rectangular coordinate. I have to change my r to a negative so that I land in the original rectangular points. That's beautiful feedback for me. So here's what I'm taking away from that. I add 180 to get my angle, but I change the sign over here to get back to where I need to be. Thank you, Gabrielle. Now, very quickly before you leave, because I hear you have to leave in 3 minutes. This next one, you need to see so that you're prepared for. I am not going to do the r squared computation because it's just tedious and we could all do that, right? Add that up, square root, we're done. But let me show you what happens over here when I set up my other formula. I take my y over my x, I'm looking at 10/8. When I reduce that, I'm looking at 5/4, right? And I'm concerned because when I think about my circle, I don't care how good I memorize that thing or how many beautiful triangles I draw, I don't anticipate seeing a y of 5 and an x of 4 anywhere. Because all my x's and y's are like 1/2, square root of 2 over 2, square root of 3 over 2. And you will find yourself in this situation in your homework. So you need to think about something else. This is calculator active now. You can't use your circle, you can use your calculator. How is it, especially knowing that I have my calculator as a tool to help me, how is it that I can cancel a tangent? Inverse tangent. So I get to just say, all right, cool, I can't use my circle, but let me go put an inverse tangent on this. These cancel. And theta is going to be whatever my calculator tells me, tangent inverse of 5/4 is. You'll want to be in degrees so that you get an angle that makes sense in terms of rotation. And your calculator will give you one answer. What are you going to do to get the second answer?
Plug in whatever you have on there.
Think visually. If it gave me an angle over here, I would add 180 to get to the other one and change the sign of my ring. Yeah, good. All right, that's it from me. Let me make sure it's actually 10:25. Yeah, thank you. Oh, then my face is going to be like right.